Hello everyone, welcome to the YouTube channel of NG Core. In this video, we will have a look at 5G network performance monitoring using KPI xApp. So here is the complete topology with the 5G core, the GNB, simulated UE, the Near RT RIC where we deploy our KPI monitoring xApp. So the first step is to install the dependencies. After that, we have to install Swig. Swig is basically a compiler that integrates C and C++ with languages such as Perl, Python, Ruby, etc. Now we go inside the Swig directory, and now we will switch to the release 4.1. Now we will run the autogen script to prepare the build environment and generate a configuration script along with the necessary files. The next step is to run the configure script, which sets up the Swig build, and you can provide flags to configure it according to your system. We have used the prefix flag, and this provides a directory where we want to install Swig. We have chosen the user folder for this. So the next step is basically to compile the Swig source code using make tool, and the -J8 option enables parallel compilation with 8 jobs, speeding up the process by utilizing multiple CPUs. The next step, sudo make install, is to install the compiled Swig binaries and libraries to the designated location, that is in the user folder given in the previous step. Now we have to check the GCC version. In our case, it is version 11, but for this deployment, it is recommended to have 10, 12, or 13. So we will switch it to a different compatible version. Next, we check whether Docker Compose is installed or not. So here we can see the version, so we can proceed forward. Now we will run our 5G core. So we can check the current health of our 5G core. Currently, some of them are healthy and some of them are starting. So once all of them are in healthy state, we can move to the RAN part. So first we are cloning the RAN repository into the OAI directory as specified. Once we have it cloned, we can move inside, and then we will switch to this particular branch, OAIC Workshop 2024 version 1. So now we go inside the CMake targets to build our binaries. We run the build OAI script to build our binaries. Now here at the bottom, you can see it clones the FlexRig module. You can also see the FlexRig components being compiled like the E2AP encoding, KPM SM encoding, and other components. So this build was successful. We can now move forward. So now we will clone a separate FlexRig folder. Once it is cloned, we will move inside and work on this particular commit. The next step is to create a build directory, move inside it, and run the CMake command. And this CMake command is used to generate the necessary build files from the CMake configuration given in the parent directory. You can see the ASN encoding for the E2AP, KPSM, and RCSM. Now this command compiles the FlexRig module using the make tool, and the -J proc option tells the make command that it needs to use as many parallel jobs as there are processor cores, speeding up the build process. This command compiles all the source files into executable binaries. These are the installed configuration and binaries. Additionally, it is using the user local lib path. Now we check the core again and see that is up and running. Next, we will run our Gnode B. So first we have to move inside the CMake targets, RAN build and build folder, and we will run this command to start the GNB. Now we have to check if AMF is connected or not. So if you see over here, you can see that AMF is associated and NGAP layer has started. This means our core and RAN are connected. So these are the logs related to FlexRig. We can see the E2 agent over here. So you can also see the IP and the port of Near RT RIC over here. Now further, you can see the generated frame slots. And now we will run the simulated UE using this command. So now we can see it is connected and running. And moving over to the RAN logs, we can also see that it's working fine. And this means that our UE is successfully connected. Now we have to start the Near RT RIC. We will run this command to start the Near RT RIC. So here you can see the IP and the port, which was assigned to Near RT RIC in the GNB logs previously. So we can see the E2 setup request has been received and Near RT RIC is connected. And we also see the accepting RAN functions. We primarily need ORAN E2 SIM KPM and E2 SIM RC. And we have our RAN and UE logs over here. So now we will exchange traffic between network and UE. First, we test for uplink ping from UE to network. We ping this particular interface, OAI tunnel, and to check the downlink ping for network, we use this command, and the IP at the end of this command is the IP of UE. Now we will go inside the FlexRig folder and we will run this script to start the KPI monitoring xApp. And here we see the setup request is transmitted and then it receives the response. The xApp ID is 7 and we have one registered E2 node. Now, once the node is connected, it sends subscription request. On receiving the response, we confirm that the subscription is successful. Now, this is the complete xApp log. You can see. So you can see the xApp ran successfully and then it stopped. Here are the KPM xApp logs with the associated values. Now we will stop the GNB and the UE simulator. So once it is stopped, and the Near RT RIC now with no GNB running, it initiates the SCTP shutdown event and we see the removed E2 node. So this was the complete demo of KPI monitoring xApp over 5G network. Thank you for watching.